Question 4th. If x minus iy is equal to square root of this complicated expression a minus ib upon c minus id, prove that this x square plus y square whole square is equal to a square plus b square over c square plus d square. This is equal to this. Now, how do we go about proving this? Okay, let's take a look at this. Now, I'll discuss two methods with you. Two methods, yes, let's discuss two methods. One is a smarter way. Let's do it with a smarter way first. Another is a longer way. Probably you would have seen that somewhere, maybe. But let's do it with a smarter way first. What I'll do is, we're given that x minus iy is equal to square root of a minus ib over c minus id. Now, what I observe over here is, this is a square b plus b square, this is c square plus d square. It has got something to do with this numerator and this denominator over here, right? And x square plus y square whole square is also present. So, x square plus y square has something got to do with this. Basically, it is x square plus y square is nothing but modulus square of x minus iy, right? If x minus iy is a complex number, we take its modulus. What do we get? Under root of x square plus y square, yes. So, we will go in that direction only, but first let's remove this square root from here and let's write it as this. A minus ib over c minus id. This is what you have, right? And once I reach this stage, there are two complex numbers on both sides, LHS and the RHS. What I'll do is I'll take modulus both sides. So, what I'll do is, since this is equal to this, their modulus would also be equal. So, take modulus both sides. And what does it give us? This gives me modulus of x minus iy whole square can be moved outside the modulus, shifted outside the modulus, and this can be written as a minus ib upon c minus id modulus. Okay. So, for the time being, you can also write it as, let us say, x minus iy square and modulus. Now, let us apply the properties of modulus and convert this further into, this is x minus iy modulus square is equal to, this is modulus of z1 upon modulus of z2, which can be written as mod z1 upon mod z2 upon mod of c minus id. Now, what is modulus of x minus iy? Let's try to find that. Modulus of x minus iy is under root of x square plus y square, okay? And yes, there is a square over there, okay? What happens over here is, this is a minus ib modulus. What is the modulus of a minus ib? That is under root of a square plus b square. What is the modulus of c minus id? That is c square plus d square in the denominator, okay? This is under root on the right hand side. Why not square both sides? We can square, but let's first square with this. What you get is x square plus y square equals under root of a square plus b square by c square plus d square, and you may now observe getting the final result in a single shot, that is squaring both sides. You will get x square plus y square whole square is equal to a square plus b square over c square plus d square. And is that what you wanted to prove? Yes, we wanted to prove this only. So, with the given condition, we have reached the equation which we wanted to prove. We have reached this stage with the given condition by a series of manipulative steps, that is taking modulus and all, and that is giving us the final proof over here, right? But you talked about two methods, right? There's another method, there's another approach which we can follow over here. Should we discuss that? Yes, let's discuss that. X minus iy is equal to a minus ib over c minus id. What you will do is, you will square both sides first, okay? There's another method, the other method I am discussing now. Instead of taking modulus both sides, what you will do is, you will simplify this. Now, how do we simplify this? I'll write a few steps to give you a glimpse. Let me write a few steps. A few steps, yes, just a few steps, because the solution will be pretty long in that case. Let me just write the square. This is x minus iy whole square. What will that convert to? This is x square. This I square y square, that will become minus y square, and minus 2xyi is equal to we'll have to multiply with complex conjugate of C minus ID in the numerator denominator. This is A minus IB C plus ID over this is C square plus D square in the denominator. Okay, multiply the terms on the RHS, simplify them and compare the real parts. First compare the real parts together. Real parts x square minus y square would be equal to something. 2xy would be equal to something. Yes. And on the basis of that, try to find this expression. Now what is this expression? This is x square plus y square whole square. So first we'll have to find x square plus y square, right, with the help of that. Now that will take a long time and it will be pretty, the steps would be many, there would be chances of silly mistakes, but then this is another approach which you can follow and to get the final result, that is this. Pretty long? Yes, pretty long. The first one is pretty simple and that is something which you can follow. I have just explained that first method and that is pretty simple which you can follow very easily, right? That is all in this question.